So let's look at conjugate pairs. In example 1c, we're going to note that the two complex zeros, 2i and negative 2i, are complex conjugates. Complex zeros occur in conjugate pairs. So let f be a polynomial function that has real coefficients. If a plus bi, where b is not 0, is a zero of the function, the complex conjugate z minus bi is also a zero of the function. Be sure, or that should be a minus bi. Be sure that this result is true only when the polynomial function has real coefficients. For example, the result applies to this function here, but not to the function with an I in it. So let's try example 6. Find a polynomial function with given zeros. Find a fourth degree polynomial f with real coefficients that has -1, -1, and 3i as zeros. So if you remember, to write this, it's always x minus, and whatever the zero is. So in that case, we write it as factors. So if this is a -1, it's x plus 1. Then there's another x plus 1. Then we have x minus 3i. We have x plus 3i, and then we have to have the conjugate pair, x minus 3i. So now what we need to do is to multiply it all the way through in order to get that fourth degree polynomial. So I do this one first, x squared plus 2x plus 1, and this is x squared minus 9i squared. So x squared plus 2x plus 1, and this becomes x squared minus 9 times -1. So this will end up being x squared plus 2x plus 1 times x squared plus 9, and then we'll distribute. So this becomes x to the fourth plus 2x cubed plus x squared, then 9x squared plus 18x plus 9. And so our final function will be x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. So I want you to go ahead and try this next example. Find a fourth degree polynomial function f with real coefficients that has 2, -2, and -7i as zeros. So pause the video and try this out. So if you tried this out, you would have gotten x to the fourth plus 45x squared minus 196. So let's try one last example together and one on your own. We're going to find a polynomial function with given zeros. So we're going to find the cubic polynomial function f with real coefficients that has 2 and 1 minus I as zeros, and it also gives us the point f1 equals 3. So when you have this, what we're going to solve in this case is that we're going to solve for a. And the other example, example 6, we didn't have enough information, but now with these ones, I actually do. So let's try to do this problem like we did earlier. Remember that when we write this, it's always x minus and whatever the factor is or whatever the zero is that they gave us. So x minus 2. So we have 1 minus I. We're going to have an x minus 1 minus I. And then the conjugate of 1 minus I is 1 plus I. So we're going to have an x minus 1 plus I. Let's go ahead and write that out. So we have f of x equals x minus 2. Then the next one we write x minus 1 minus I times x minus the 1 plus I. So we have these here. So one thing that we can do is we can distribute the negative. So I can do that, x minus 2. So this becomes x minus 1 plus I. And then the other one is x minus 1 minus I. And the next thing we can do is to regroup. So I'm going to group that x minus 1 together. And notice what happens when I do that. This is a conjugate. So we have a plus b times a minus b, which is awesome. That makes multiplying this so much faster. So let's do that. Let's multiply x minus 2. And then in here, this just becomes x minus 1 squared. It's the a squared minus b squared. And so that's x minus 1 squared minus I squared. Then let's expand it more. X minus 2 times x squared minus 2x plus 1 minus 1 times, or minus negative 1. Okay, so it's just a negative 1, no times 1 there. Then let's simplify this further. X minus 2, and this is x squared minus 2x. This minus minus becomes plus, so it actually becomes a 2 at the end. So let's go ahead and multiply all the way through. So this is now x cubed minus 2x squared plus 2x, and then minus 2x squared plus 4x minus 4. So now our function, and I'm sorry, we are going to figure out our a value, so I should rewrite that with everything. So f of x equals a times x cubed minus 4x squared plus 6x minus 4. So now we solve for this, we need to go ahead and solve for a. So remember that f of 1, so the 1 represents our x, and the 3 represents our y value. So f of x, that is 3, equals a times 1 cubed minus 4 times 1 squared, plus 6 times 1 minus 4. So 3 equals a times 1 minus 4 plus 6 minus 4. So 3 equals a times negative 4, that's negative 8, plus 7 is negative 1, divide by negative 1. So we know that a equals negative 1. So now that we know our a value, we're going to go ahead, I'm sorry, not negative 1, it equals negative 3. I said negative 3, just wrote the wrong thing. So a equals negative 3. So now we're going to plug that in as our a value to our function. So we have f of x equals negative 3 times x cubed minus 4x squared plus 6x minus 4. And then we're going to distribute. So negative 3x cubed plus 12x squared minus 18x plus 12. And that is our final function. So now here's one more example for you to try out. Find the quartic or fourth degree polynomial function f with real coefficients that has 1, negative 2, and negative 2i as zeros, and f of negative 1 equals 10. Pause the video and try it out. So if you tried this out, making sure you're careful with all of your signs and everything, then you would have gotten negative x to the fourth minus x cubed minus 2x squared minus 4x plus 8. So I hope this helps. Thanks for watching.